Okay, so I'm going to repeat what I said before. So when we are using this method, it's just like using multiplication and division. 2 times 3 is 6, and 6 divided by 2 is 3. All right, so let's drag in an x squared, 3 x's, 2 x's, and 6 positives. All right, Patrick, help me. So if I were to factor out this x squared, what number times what number makes x squared?
1.
1 times 1 makes x squared?
Oh, 1 times x.
1 times x makes x squared?
X times x.
X times x makes x squared. X times what makes 1x?
1.
And 1, and 1, and 1,
There you go.
and 1. So if I were to multiply x plus what class?
3.
3 times x plus 2, I would get x squared plus 3x plus 2x plus 6. All right, so write this down. Okay, so let's begin with what we did yesterday. Yesterday we distributed it in reverse. Distributing in reverse is the same thing as factoring out or dividing, right? So let's factor out or find our greatest common factors of all of these. Okay? So what does 3x to the fourth, 9x to the cube, 9x cubed, negative 6x squared, and positive 12x all have in common? What's the greatest common factor? They have a 3, and they all have an x. So if I take 3x, and what would I multiply 3x by to get 3x to the fourth? X cubed. And 3x squared, negative, good job, and positive 4. So today, let's do the box method in reverse. So before we had 2 binomials, and we set them up on this side and this side, this side and this side, and when we multiplied, we got the product, which would be x squared plus 3x plus 2x plus 6. So I'm going to do the inverse of that right now. I'm going to find all the greatest common factors and factor out what I would have originally multiplied. So what's the greatest common factor of x squared and 3x? X. X times what makes x squared? X. X times what makes 3x? 3. 2x and 6. What are their common factors? 2. And I like this way because you actually get to double check if you're right. Does 2 times x equal 2x? Does 2 times 3 equal 6? Yes. So I have x plus 3 times x plus 2. Take all this and move it over here because that's our answer. And if we go back, isn't that exactly what we got here? Isn't that what this looks like? X squared, 3x up in the top, 2x on the bottom, 6 on this side? Doesn't that look exactly like this? Okay, let's move on. All right, let's summarize this. So this is what I call the new school, the new way of looking at this and thinking. All right, it's organizing things. Back when I learned it, we just did the standard grouping. So I'm going to kind of show you how those two line up. So let's think about how we group these. Well, how do we group this? I grouped x squared and 3x in one column, correct? So let's group them together here. And I grouped 2x and 6. Let's group those. Can somebody tell me what the common factor of x squared and 3x is? X. And the common factor of 2x and 6?
2.
2. And sometimes you make errors doing these, but I think this way it's really hard to make an error. It really, truly is harder to make an error. Okay, so that's the first thing I would do, was group them together. The second thing we would do was take out the greatest common factor, or factor out the greatest common factor, which would have been x for this one, and 2 for this one. And lastly, what do you think I would do? Before we go there, let's do this. What could I factor out? What do x times x plus 3 and 2 times x plus 3 have in common? No. No. X times the quantity x plus 3 plus 2 times the quantity x plus 3. These two terms have x plus 3 in common, don't they? So I could factor out x plus 3. What would I multiply x by 3 to get x times x plus 3? And what would I multiply x plus 3 times to get 2 times x plus 3? Isn't that what we got before? X plus 3 times x plus 2. Isn't that what we have here? And that's what I got here. See how the two relate? I don't expect you to do this way. You can do it this way each and every time you want to do it. But I'll show you how, as you can kind of start stumbling with this one. This is pretty clear, exactly what you need to do. So let's move on. I want you to write down these 3 problems, and we're going to do each one of them both ways. And then after I'm done, you can pick which way you want to do these. Fair enough? Give you a second to write. Okay, so I guess I'll make it pretty. Uh-oh. I'm okay. I'm alright. I'm not gonna... Oh, I did it again. I know. It's okay. Alright. I'll just have to deal with it. What does 3y times y plus 5 and 2 times y plus 5 have in common? Y plus 5. So when I factor out y plus 5, what am I left with on top? When I factored this out, what am I left with? 3y. And when I factor out y plus 5, what am I left with over here? Positive 2. So that's my answer. Let's do it this way. When I factor out, hold on, I'm skipping a step. The step we've already tried to group them. Okay? I'm going to go back to the box method in the next slide. Okay, Randy? So just bear with me. When I factor out y plus 5, what's left over? If I get rid of this and this, factor it out. What's left over? You know what I think we need? I think we need an easier example. So how about something like this? 2 times 3 plus 2 times, say, 4 times 3. What does this equal? 2 times 3 is 6, and 4 times 3 is 12. So what does this equal? 18, correct? Well, let me take this and copy it to another page. What do these two have in common? Randy, what do these two have in common? They're both being multiplied by 3. So if I factor out a 3, what am I left with? If I factor out a 3 from this one, Randy, what am I left with? 2. And if I factor out a 3 from this one, what am I left with?
4.
Correct? What's 2 plus 4? What's 6 times 3? See that?
Okay.
See what I'm doing? I'm just taking pieces of it away. In fact, I'm saying, what do you both have? I'm going to pull that out of the parentheses. Exactly. So let's do that again. What do these two have in common? 4x minus 1. Randy, if I factor out 4x minus 1, what's left up here? And what's left over here? That's it. If I were to do that over here, I would simply just say I have a common 4x minus 1. When I factor 4x minus 1 from this one, I get 2x. When I factor out of this one, I get this one, 5. Yeah. Oh, that's a good, like, cross that out? Okay. Randy, I'm guessing you're probably going to use the box method anyway, so it's not going to matter. Okay? I'm going to factor out the x minus 7. X minus 2 is left over. Am I going too fast? X minus 7 is factored out. X minus 2 is left over. Which one do you like better? The left? I said the left too until the next slide. I thought, you know what? The whole box method, the organization of it makes a lot of sense. May I go? All right, why don't you guys factor number 4 completely using the box method or group first? The grouping method or the box method? Okay, so if I were to look at this, I'm going to do these simultaneously. I'm going to do a box. Actually, let's do the box first. Okay, so where would I put 4AB?
At the corner.
Top corner. 4AB,
Well, you can have to put it in
8B, 3A, 6. What's the common factor of 4AB and 8B, Randy? The common factor of 4AB and 8B.
4.
4, what else? What do they both have in common?
B.
B. What would I multiply 4B by to get 4AB?
4A.
And 4B times what makes 8B?
2.
2. 3A and 6, what do they have in common?
3.
3 times A is 3A, 3 times 2 is 6, so we're correct?
Yeah.
So the factors of this should be 4B plus 3 times A plus 2. Or, okay, or we would group them. If you're just grouping, like Anthony said he likes, would I group 8B and 3A, Anthony? Would you group those together? There's nothing in common, so you wouldn't group them. I'm looking for common factors. So let's group that one and that one. What are the common factors of these two? 4 and B. See how it's harder to see than it is over here? For some reason, it's so much easier to see it than over here. So 4B times A would make that. And 4B times 2 would give us this. Plus, what are the common factors over here? 3. 3 times A plus 2. Now we have this common and this in common with these two terms. So I could factor out A plus 2 and I would be left with, this looks just like the last screen now, right? I would get 4b plus 3. Which one you guys like better?
The other one.
This one?
Yes.
Anthony, you still like this one better? You like this one better? Okay. So does everybody agree that we're only going to do this one on the last one?
Yeah. This one, what is that called? Boxing?
Yes, it's the box method. It's organized. It's organized. You can put stuff in boxes. That's true. Negative 8x, positive 20. You guys try that one. All right, what's the common factor here? 3x. 3 times what makes 6x squared? 2x. And over here? Negative 5. And over here, what's the common factor? Negative 4. Nope, not negative 4. They both don't have a negative. 4. 4 times 2x. Why did that happen like that? Because the 5 is negative. Okay, so this is a special case right here. It is negative 4 because when I say negative 4 times 2x, I get negative 8x.
Oh.
But you know that you have to do that because when you backtrack, right, and multiply, you discover that. And negative 4 times negative 5 makes a positive 20.
Hey, did you know that was going to happen?
I didn't, but I knew it was going to follow up right here. So let's do it the other way over here. So my factors, or my binomials, are 3x minus 4 times 2x minus 5. All right, let's do it this way. I would group these. You don't have to do this. This is why this works. 3x is my common factor here, and I'm left with 2x. 3x times what makes negative 15x? Negative 5. I have a subtraction sign here. This is where it gets tricky when you do it in this method. The common factor over here is 4. Negative 4 times 2x makes negative 8x. And negative 4, I have to make this a negative 5 to make positive 20. So now I have 2x minus 5 factors out, and I'm left with 3x minus 4. So tricky with this way and tricky with this way. But when you do it this way, it catches the mistake for you. Correct? And you can be double checking yourself as you go. Questions on that at all?
No, ma'am.
Okay. All right, we're going to skip over this. I think we're going to do this as review. I want to touch on this. Put your pencils down and just look up here. How would I do this one? What would I use? What kind of method would I use for this one? Yeah, I could divide, right? Or factor out. What would I factor out? 2m squared. I'm not going to do all of them because I want to give you some homework time. I just want to see. What would I do with this one?
Box.
A box. What would I do with this one?
Box.
A box. If there's 4 terms, you can use a box. What about this one? Can you use a box with that?
No.
No, so I would just do that division method. Or factoring out. That one's hard?
It's okay, we'll just do it.
You need practice is what you need. Okay. So why don't you go ahead and rate how our content objective was met today. How did you do today? 1, 2, 3, or 4?
I'm going to put 5.
And here's your homework. Why don't we get started? That's all for today. Good job, guys.